All right, cool. So here we go. Let me introduce the amazing Dr. Valerie Schutz. She is a professor in the Department of Educational Psychology and Learning Systems at Florida State University. Before coming to FSU in 2007, she was a principal research scientist at Educational Testing Service, where she was involved with basic and applied research projects related to assessment, cognitive diagnosis, and learning from advanced instructional systems. Her general research interests, however, hover around design, development, and evaluation of advanced systems to support learning, particularly related to the 21st century competencies. An example of current research involved using immersive games with self-assessment to support learning of cognitive and non-cognitive knowledge, skills, and dispositions. Her research has resulted in numerous grants, journal articles, books, chapters in edited books, a patent, and a 2010 book entitled Innovative Assessment for the 21st Century, Supporting Educational Needs. Let's give Dr. Schutz a warm welcome. Thank you again for joining us today.
What I'd like to do is talk about some of my current research on games, learning, and self-assessment. And this is in relation to 21st century competencies or 21st century skills. And then I'll briefly share how I actually got to this point. The reason this research is important is because you can see in this picture here, the world has changed a whole lot in the last 100 years, but education really hasn't. Now, 100 years ago, if you acquired your 3 R's, that's reading, writing, and arithmetic, you were thought, to be sufficiently literate because the goal back then, for education was to prepare young people for production jobs. Something like 90% of the students were not expected to hold any kind of professional career. But today's kids, which are you guys, need a whole new set of skills in order to be successful citizens in today's world. For example, when any of us are faced with a complex problem, we absolutely need to be able to think creatively and critically and systemically and work collaboratively with others and also be able to communicate effectively. Now, there's a bunch of different things that go by the name of 21st century skills, and here's a few of them that my students and I are currently studying in relation to, what kids are learning in game environments, things like critical thinking and systems thinking and curiosity and so forth. The two that I'm going to focus on today are these two, persistence and creativity, which I think are really important constructs, but they're really hard and slippery to measure, so that makes it all the more challenging. Okay, so one of the main problems that's standing in the way of schools fully embracing these new kinds of competencies is that there's not really any good, valid, and reliable assessments for them. And our old ways of doing stuff, our old ways of testing, don't work because learning and succeeding in this new world of ours can't be optimally measured by the same old kinds of multiple choice tests or self-report kinds of tools. So we need to rethink assessment, and my position is that we should use games as vehicles to assess and support some of these new competencies. So here's how I'm measuring new skills. It's called self-assessment, and some of the features of self-assessment are that it's seamless. That means that assessments are woven right into the fabric of the code of the learning environment. They're ubiquitous, and that means that the ongoing data are collected during gameplay. And also it produces valid and comprehensive models of the learner or the player with regard to the knowledge and skills. And the way this works is I'm using this approach called evidence-centered design, and it begins by defining 3 main models. The first model is addressing the issue of what all do you want to say about the person. This is in terms of the knowledge and skills and the beliefs and the dispositions of the person. Next is the evidence model, which has to do with addressing the issue of what observations do I need to make that would provide the best evidence for what I want to say in relation to those competencies. And finally, the last model is the action or the task model, which addresses the issue of the kinds of tasks or situations or quests that will allow me to make the necessary observations. So the self-assessment approach uses evidence-centered design to make these models and then embed them deeply into the game environment. And this is made possible because there's been a lot of advances in measurement in the last decade or so, and this allows us to extract all sorts of ongoing information from a learner during gameplay and then make accurate inferences back to competencies. I'll show an example of this in a second. And also be able to react in immediate and helpful ways. So when assessment is so seamlessly woven into the fabric of the environment that it's invisible, that's what I mean by self-assessment. Okay, now the way this works is that during gameplay, just like with any game, players produce rich sequences of actions, while they're in the process of playing the game. The two pictures I have here, one is from Oblivion, and the other one everybody knows is from Angry Birds down there. So when you're playing these games, the actions that you take in the game are drawing on a variety of competencies, whether it's problem-solving skills or creativity, persistence, conceptual physics understanding, whatever. So the evidence that's needed to assess the competencies comes directly from the player's interactions with the game itself. Okay, so what I'm going to do is describe the game that I'm using in one of my current research projects. The game is called Crayon Physics Deluxe, and it's a computer-based game. It deals with two-dimensional physics simulations. It models stuff like gravity and mass and kinetic and potential energy and transfer of momentum and all the different words that you learn maybe in high school physics that don't really make much sense to you, but when you're actually playing the game, you're inventing some of these concepts yourself. So it becomes very conceptually part of your understanding. So let's see, in all the problems, the objective, and there's like 7 different islands in the game, and they increase in difficulty, and on each island there's maybe about 15 different problems to solve. And in all cases, what your goal is as a player is to get this red ball from some starting point over to a star. There can be a couple of stars that you have to get depending on the difficulty of the problem. So everything in the game obeys the basic rules of physics. Again, like gravity and Newton's 3 laws of motion. So what you do on the computer, on your iPad or whatever, you draw physical objects, and these objects come to life after you draw them. And so the game lets players solve problems in lots of different ways. There's no one right solution. And as the game says, it's not about finding just any solution, it's about finding the awesomest one. I'll show an example in a second of one of my awesome solutions that I actually came up with. So here's a 30,000-foot view of some of the models that we're examining in relation to the game. We're looking at creativity and consciousness and conceptual physics understanding. So let me show you what each one of these models looks like broken down a little bit, because I can say, oh, I'm measuring your creativity, but that's very vague and general and doesn't communicate anything. So what we've been doing is developing these, quote, models of our different constructs and then using those as the basis to say, okay, this is what we're talking about and this is how we'll measure it in the game. So look at creativity right here. There's 2 different aspects to it. There's cognitive aspects of creativity and dispositional ones. Dispositional ones can be things like your openness to experience, your willingness to take risks, and so forth. With the cognitive skills, some of the things we're looking at are fluency. You know that as divergent thinking or brainstorming. It's the number of different ideas that you can come up with to solve a problem. Or another aspect is originality, which is the novelty of your solutions. So You can, for instance, come up with 100 different solutions, and they can all be lame and not very novel, or you can come up with just a couple, and they could be highly original or not original at all, and so forth. So here's some of on the far right side of this picture. I don't know if you can see it very well, but these are some of the indicators that we look for in gameplay. So, for example, if we wanted to measure a person's fluency, we would look at, for instance, the number of solutions that a person generates for every problem. So in the game itself, it was very common for me to play any given problem maybe a dozen to 20 times, always trying to come up with a better and better solution. Originality can be measured by the number of different agents of motion. Those are different objects that you use relative to others. So if I come up with a solution nobody else did, well, that would be pretty novel. And here's our model for conscientiousness. Again, we're looking at things like persistence and perfectionism. I'll just show some examples here. Like for persistence, we will look at the time spent on an unsolved problem, especially a difficult one. So, for example, when you come across, somebody asked what the game's called. It's called Crayon Physics Deluxe. You can download it on your iPad. I think it's $6.99, or on a PC version. So if you come to a hard problem and you stick with it for a really long time until you finally solve it, that would be a good indicator of persistence. But if you come to a hard problem and you go, oh, forget that, and you skip it, that's not a very good indicator of persistence. So that's basically what we're doing. We have all these models set up, and we're measuring what people actually do in the game environment. So, Amy, can you, I want to insert the gameplay right here. Amy, can you hear me? Oh, okay. Can it, now to set this particular problem up, I had just solved this particular problem, which may or may not show up. I'm not seeing it on my screen right now. But what I had done was I was trying to get the ball over to the star, and I had done it about 10 or 12 times, and they're all kind of kludgy solutions. Is anybody able to see the problem here? Yeah, I see a blank web page too. Amy, let's see.
I'm going to try it again.
Let's try it again. Hang on. Okay. So I could go ahead and talk while she's doing it. At some point when I was playing the game, there's a big pit that you'll see, or maybe not. But the problem was kind of hard, and I had created a pendulum solution to bop the ball, but it kept falling in the hole, so I had to use some kind of ramp solution. And at some point I realized that if I could make a more elegant solution, I could do it with like a scooping mechanism. I had solved the problem with a single object. I had devised this kind of scooping mechanism which came around as a pendulum, scooped up the ball, and then elevated it and dropped it off directly on top of the star. It was really cool. I'm sorry you can't see it. So anyway, at the end of that problem, the computer would have scored my persistence as high because I had spent about 30 minutes on the problem and about 13 different trials. And also, it would score me as being kind of high on creativity because it was a novel solution. Nobody had done anything like it. We'll go ahead and just blow that off right now. I don't think we can see that. So, in a nutshell, what self-assessment allows us to do is extract all this ongoing data from a user during gameplay, and that allows us to make valid inferences back to different competencies. So I could say, oh, you're really creative. In particular, your divergent skills are really excellent. And we could talk about those at any time and at any grain size. Those data that are captured can then be converted to information that can be used by the student, by the teacher, by the parents, or whomever, and they could be directly acted on. So, for example, it could provide feedback to the student. It could provide targeted support. It could even provide information to make changes to the environment. Like if somebody is clearly floundering, then, you should ratchet back the difficulty a little bit. So another thing that I'm looking at is whether I can recycle some of these models, like for persistence and stuff in other games, and that would be a real cost-effective kind of thing. So what I did was I anticipated some of your questions and went ahead and answered them in relation to, the first question was, tell us about your current position. And as somebody indicated at the beginning of this, I'm a professor at Florida State University. I'm in the Educational Psychology and Learning Systems Department, and I do a whole lot of research. This project that I was talking about is just one of about 4 or 5 different current research grants that I have. I also teach graduate students in courses such as measurement and writing and researching skills. And I do lots of other duties, like I'm an editor of the journal called Instructional Science. I presented conferences, and I simply love my job very much. The game, again, is called Crayon Physics Deluxe. As far as schooling, I picked my schools very carefully. I ended up going to, I got my bachelor's degree in psychology and biology at the University of Northern Colorado. And then for my master's and my PhD, I went to the most beautiful school in the world. You see a picture of it here. It's called University of California, Santa Barbara. We called it University of California, the Surfing Branch. As far as working in a position that I thought I'd be when I graduated from college, I didn't really know what I was going to end up doing, but everything that I ended up doing was very, very fun. I knew that I wanted to study the human mind. That's all I knew. People just fascinated me, and I knew I needed a lot, different kinds of skills in order to accomplish that. So what I ended up doing was I created my own kind of multidisciplinary program for my PhD, and that involved a bit of cognitive psychology and endocrinology, which is the study of hormones, and artificial intelligence, and also statistics. Those are a few of my favorite things. My grades in high school were okay. They were A's and B's. My motivation to get into this field was, basically people fascinate me. And another thing that really motivated me was to find a way to cure ignorance. And also, I'm passionate about reducing or eliminating the achievement gap. And I also want to enhance learning of important things, whether it's math or science, creativity and persistence and empathy and tolerance, problem solving. And I want to be able to do it for everybody and do so in a fun and engaging way. And I've been a gamer since I was a little kid. So the best and worst parts of my job, the best part is that I get paid to play every single day. Like yesterday, I just finished, after 73 hours, I finished the boss level on Portal 2, which is probably the best game I ever played. And that was just part of my work day. Oh, I've got to go play Portal 2. The most challenging part is because I work really hard, I have a lot of persistence. I end up with a lot of things that I need to juggle. And in cases like this, it's really important to be able to prioritize and manage your time really well. I think what made me become a gamer is just, partly it's the intrinsic nature of games themselves, which are, just completely compelling to some people. But also when I was young, my dad got me a subscription to Games magazine. I don't know if they have that anymore. And that and National Geographic were my 2 favorite magazines in the whole world when I was growing up. Let's see, I think I skipped one. What does your typical day look like? That's actually me on a zip line last year in, I think that was Jamaica. So I'm up real early, and I'm drinking my iced coffee over Facebook and then settle into my work day. And I'll do any number of different things. I'll teach, I'll read research papers, I'll meet with students, which I'm off to do right now. I'll write research papers, I'll review other people's papers, and I chat with lots of people. I spend a lot of time responding to email, and then more time spending games and thinking about research as I'm doing it. And I also travel a whole lot. And yeah, I guess playing games, I don't know about whether it makes you feel like a kid. It just makes me feel good because, like with anybody, you know, when you solve a really hard problem, it just feels so good. You feel so very satisfied. So, how many hours a week do I work? Well, I put work in quotes because, you know, I don't actually work. I enjoy what I do. So I get up around 6 a.m. and, you know, I'll quote work until 9 p.m. and then go watch something like Hoarders or The Voice. But when you love something, it's, you know, and it's not something that you have to do, it's something that you want to do. So every day I realize, you know, just how lucky I am. And as far as how many games I play a day, I like to focus on, you know, I'm a pretty much a serial kind of person, so I devoted all my love and focus into Portal 2 for the last couple weeks. Again, best game ever. Oops. Sorry. Like the previous speaker, how much time do I spend on continuing education? Well, the answer is all my time because I am a lifelong learner. I'm, you know, chronically a student, and, you know, hope you all will be too. The average salary for a person in my position, well, I had to look that up, and according to Wikipedia, the annual salary of full professors is something like $99,000. And that's for a 9-month salary. So my summers are off. I just submitted my grades yesterday. So from now until August sometime, I'm doing research. And this figure also doesn't include consulting monies that I get. So full professors earn something like 70% more than assistant professors. And I should also point out that this amount is much less than you would get for doing the same stuff in industry. For instance, when I left Educational Testing Service to come down here, I took a huge salary cut, but it was fine because I have much more freedom as a professor than I did working at Educational Testing Service. The advice that I give are pretty much echoed what the previous speaker was talking about. The idea is that empowerment comes through education. So it's really important that you guys really accept that, yeah, education opens a whole bunch of doors. Second bit of advice is, you know, have a dream, make it a good one, and then go after it with all of your powerful energies. And know that it's okay to fail. I think this was a quote here by Ralph Waldo Emerson. Our greatest glory is not in never failing, but in rising up every time we do fail. So each of you is unique. Each one of you has a particular contribution to make to society. So, I think that's it for me. And now I'd love to entertain any questions that you guys have. Moderators, did you want to pull through some? Somebody's asking about, is it hard to make games? The answer to that is yes, it is. And there's people who are really, really good game designers, and sometimes people think it's real easy, and when educators who don't have a good background in game design go to make a game, invariably it is not a very good game. So the solution is to couple game designers with educators and assessment experts at the beginning to be able to develop really good games, things that are engaging, that involve adaptive challenges, that provide ongoing feedback and provide elements of, that capture your curiosity and things like that. I work at FSU, somebody just asked. And yes, I do travel a lot. And yes, go Seminoles. I have about 3 trips this month in various places. And absolutely, game designers hire kids to test the games. In fact, with the port, I have a grant to investigate, to develop some stealth assessments in Portal 2. And what I'm doing is I'm developing models for problem-solving skills, spatial abilities, and conscientiousness in Portal 2. And what they're doing, and so I'm actually working with Valve Corporation, which are the game designers who created Portal 2. And they have a laboratory where kids come in and test out the games and so forth. And I currently, with the Crayon Physics project, I am working, I'm doing some pilot testing and then a study at Florida State University, FSUS. But I'm always looking for students to to beta test some of these games.
Dr. Shute, one of our students has asked, what is the age range for your Crayon Physics lab?
Yeah, but
Dr. Valerie, I think we lost your audio. Can you click your microphone again? I think you had an answer to the awesome question.
Okay. Did you hear any part of the response? About
I don't think we did. Sorry.
Okay. So with regard to the age range, it has to do with I've tested it on kids as young as 4 and 5, but they don't have the necessary background to understand the conceptual physics that are involved in it. They can do it through trial and error. I'm testing middle school students, grades 6 through 8 at FSUS in a study with Crayon Physics, but it's actually intriguing for everybody of all ages. And I am in my 50s right now, and it's completely compelling and engaging for me. I spent about 35 hours on the game, solving it in lots of different ways. So a really good game doesn't have age boundaries, but if I really wanted to have kids walk away with an understanding of conceptual physics, like in terms of Newton's laws of motion, then you should probably be about middle school, I guess.